Hello. Today we'll talk about PaLI, a jointly scaled multilingual language image model, which is again in the series from CLIP to PaLI. As you can see, this model is already called PaLI, so this builds on the PaLM model, which was Pathways Language Model, and this is Pathways Language Image Model. One of the contributions of this paper is related to scaling, figuring out that jointly scaling language and image models together is a sensible thing to do. And up until that point, so this paper is from middle of 2023, up until this point, most vision language models had large language models and smaller vision models. And they discovered in this paper that if you scale up the vision model as well, not only the vision model, but also the vision model in addition to the text model, you'll get a bump in performance. Specifically, they took the ViT, so vision transformer, and the previous biggest one was ViT-G, and I think it had 2 billion parameters, and they've created ViT-E, which stands for enormous, and it had 4 billion parameters. And then they evaluated it against text models of different sizes, I think 13 and 15 billion, something like that. So the language model was still bigger, but they showed that scaling up the vision component as well is useful. They also introduced a new data set, so they call it the WebLi dataset, which is described here. 10 billion images, I think, and like a billion text image pairs. In this section, they describe how to train. The interesting thing also from this paper, and I don't know how novel it was, whether they're the first ones to do this or not, but it is a nice idea. The way to combine vision language models is that they kind of created this common interface that can fulfill different tasks. So the interface is the model takes an image and text, and it outputs text. So reasonably simple, and they show that they show how it goes through the model. But the thing is that with this kind of interface, you can do a bunch of things. You can do image captioning by asking by asking to caption this image. You can do classification, kind of like this example. What type of flowers are in these buckets? And it answers sunflowers. So you can do classification, captioning, you can do object detection, you can do visual question answering, and a bunch of different things that have historically been solved by separate models. They can now solve them with a single model. And they show that this actually gives boost in performance as well. So when we go to experiments, they list all the different kinds of tasks that they trained on and evaluated on. So image captioning is one task, and you can see that the biggest PaLI model is doing really well, and basically on all the tasks that's the same. And the other thing that's different about this model from previous models is that it's multilingual. So they have, I think, 100 languages in the answering and so on. I think the answers are only in English, but the questions can be in different languages. You can see that again, the big PaLI model is doing well on question answering, same story, and multilingual question answering and so on. And here you can see that on different tasks, different models perform, like the more you scale up, the better your performance is. And they also have some final fine tuning with high resolution. So I think by default, the images are 224 by 224, and they also train by, I think, 500 pixels square as a final fine tuning step. And it also gives a boost in performance, which is another hint that putting more computation into this will get better results. Image classification, and then they do ablation studies, and they have a long list of appendices that are cool and interesting, but we're not going to cover here. So that's basically it. These are the main ideas of the paper. It was an actually large paper, pretty influential, and I'm now excited to read the subsequent papers of this, specifically PaLI 3, and then finally PaLI. Hope you enjoyed it. Thanks so much.